Welcome to lecture 7 Embedded C data types for 8051 with example using Keil part 2. The last class we discussed the integer data type, that is unsigned int and signed int. Today lecture I am going to be cover unsigned char and then signed character. Okay, this is the program. Just rewrote the program. Write an 8051C program to send X values for ASCII characters of 1, 2, 3, 4, 5, C, A, B, C, D, E to port 1. Just to come over here, this as include reg51h. Why I added over here? Because I am using the special function register. The P1 is available. So I want to access this P1. I have to be define this include reg51.h void main. It is the unsigned char. The same line. Okay, due to the unavailability of the space, it comes to the next line. Unsigned char. My num is an array. Whatever the value, the ASCII value I want to display on the port 1, you have to be sent with the single code. Okay. For example, 0 in the single code, ASCII value of 0, that has to be displayed on the port 1. ASCII value of 1, ASCII value of 2, ASCII value of 3, ASCII value of A to E. Here Z I am using an integer, so unsigned in Z. For Z is equal to, it is an initialization, is an condition. Okay, once the condition is true, it comes to this statement, it is going to be execute. Again come over here, it is going to be Z plus plus. Again check the condition. Okay, the condition is true. Again go inside the loop, it is going to be execute. Okay, now for example, Z is equal to 0. So 0 less than or equal to 10 is condition true. So what is the 0 value? The Z value, it is 0. My num of 0. What is my num of 0 is, in the single code it is a 0. That is ASCII value of 0. Okay, is the my num of 0. In the 0th position you having that 0. Okay, that's in the single code. Okay, so ASCII value of 0 is transferred to P1. The next Z plus plus. So now Z becomes 1. 1 less than or equal to 10. Now my num of 1. What is the my num of 1? It is the, in the single code, it is 1. So ASCII value of 1 has to be transferred to P1. Okay, just come to the Keil. I have to be demonstrate. You can able to understand better. Okay, now I'm going to be project, new mission project. The desktop, I create a folder name, it is a C programming. Here I create a project name, that is test file. Okay, it is a project name. Okay, there is not yet I started the C programming. There is no extension over here with .c. Just you can give the project name as test file. Save. It will ask you which device you're going to be. Write the code. I just select the device 8089C51. I hope you are aware of that. No. Okay, the project is selected over here. Again, new. The same program what you explained just before, I just copy and paste due to the lack of time. Here just I pasted over here. Yeah, just the same, include void main unsigned char. I want to transfer the ASCII value of 0, 1, 2 to the port 1. So if you want to transfer the ASCII value of 0, you have to be in the single code, you can pass that one. Then only it has to be transferred that ASCII value of 0 to the port 1. Now I am going to be save the same folder C programming test 5.c. Okay. Next go to the source group and add existing file and you give the name as test5.c extension, close. You just look at here the project name. I choose the device, that is 8018C51, and that device I kept my program name as test5.c. Now I am going for the control, that option for target. You have to be keep 12 megahertz. The output, it is a create X file. This is not required. Whenever you go for 8051, the real-time implementation, you can upload this X file. At the time only you can going to be this option. You go for the simulation, no need to, what is that, create the X file. Okay, for practice we can doing. Next we go for the compiling, is checking whether any error is there or not. There is no error. Next it is going to be create the X file, and it is going to be build that X file into the target file. Now I'm going to be debug. Okay, the port I'm using over here is port 1. I just select the port 1. Okay, now you see the port 1. Now I'm going to be stepwise run. Okay, 0. Okay, fine. Now you can see over here, I already written over here, ASCII value of 0 is 30. So 30 is displayed over here. ASCII value of 1, 31, 2, 32, so on. A 41, B 42, C, D 44, E 45. If you want to pass within the single code, okay, that value is considered as ASCII value. That value is sent to P1. Okay, I hope you understand. The next 31, 32, 33, 34, 35. The next 41, it is a capital A, capital B 42, 43, 44, 45. Okay, then it comes out of the loop. Okay. The next we go for the next program. Here I used unsigned char. Unsigned char, the size, it is 8 bits. The data range is 0 to 255. Here write an 8051C program to send X values for ASCII character and negative values of A -1, B -2, C -3, D -4. Suppose in this program I use only char. Okay, if you are using sign char, it will, what is that, it assume as a sign char. Suppose you are not using sign also, it will consider as the sign char only. Okay, same here. I also be whatever the value I sending through single code, the ASCII value of that value is transferred to P1. Here I am not putting any single code. What is the -1? The negative value. Okay, the negative value of -1, the X value. Okay, and B and -2, it is a 2's complement value that has to be transferred to P1. Same like -1 also, the 2's complement of -1 is FF. The last lecture we discussed, it is a F, E, and single quote there is a C. This is small c. The previous example I using capital A, capital B, capital C. Here I am using the small a, small b, small c. Okay, unsigned in for, again, is that equal to 0. Checking the condition, it is true. Minimum of 0. What is the first value? 0th value is, what is that? A. It is in the single quote. So ASCII value of A is transferred to P1. The next is that plus plus, is that becomes 1. For true, minimum of 1 is, what is that? -1. -1 means the 2's complement of -1 is FF. That FF is transferred to this P1 and so on. Due to time constraint, the same file and just replacing that one. Here you see the last lecture we discussed, +1 It is x value is 0 1. If it is a minus 1, you take the plus 1 value in the binary and you take a 1's complement. Again you add 1 over here, so it becomes a 2's complement. The 2's complement value is how much? F of minus 1 means what is the 2's complement value? F. What is that sign char data range? It is minus 128 to plus 127, because this is what is the sign char. MSB indicates as like integer. Is if it is 0, it is a plus 1. If it is 1 in the MSBB, it represented as the minus 1. Likewise for minus 2, you take the 2 in the binary number and you take a 1's complement and you added 1 over in the LSB, you will get a 2's complement. The 2's complement is Fe. Okay, the 2's complement of the minus 2 is Fe. How to indicate a negative value of 2? It is the 2's complement way you can have to be represent. The value is Fe. Now I am going to be the translate. No error. Okay, it is a rebuild. Now I am going for debug mode. Say P1. The first word is that A, small a. Small a ASCII value is how much? Yeah, it is a 61. The next minus 1. What is the minus 1? It is a negative number. It has to be represented in the 2's complement. The 2's complement, 2's complement of minus 1 is F. You see, yeah, F is displayed. Next B, it is 62 and minus 2. The 2's complement of minus 2 is Fe. Yeah, Fe is displayed over here, and so on. C is 63, FD, and D is 64, and FC. Okay, I hope you understand the logic. The next very important thing in terms of both sign integer as well as the character. Yeah, you see the ring representation just for understanding. For example, if it is a 8-bit char or 8-bit integer, what is the size? It is a 8-bit. Data range is 0 to 255. For example, if you are giving a 256, okay, what is the value has to be printed in that P1? 0 has to be printed. If it 257, it is 1. Okay, your compiler don't give any error, but what is that? 0 to 255, that value accordingly 002 FF, that is displayed on the P1. Suppose you are transferring the 255, but it shows in the output it is 0. Okay, so our point of view, we can consider that value is 0. Okay, but if you are past 256, also it is coming 0, so it is invalid. Okay, but the compiler get execute. The same file, I just replacing it. Just carefully listen it. Void main unsigned char, it is 0 to 255 only have been passed, but I am sending the values 256, 257 until 260. I take some more values 510, 511, 512, 513. The same unsigned in, because the z I am passing the integer number, and my num z equal to 0, my num of 0 is equal to 256. Just I am going for no error. Yeah, now I'm going to be executed. You will getting, you see, 0. 256, it is 0. That's why I represented over here. It is a ring representation, just for understanding. 0 to 255 only has to be accepted that 8-bit char. Even though your compiler, if you pass 256, that will, what is that? consider as a 0. Okay, it will pass to here. Okay, if it is 257, again pass to 1. Okay, and so on. But if you are passing the 256, if you are coming 0, okay, there is a contradiction. Okay, why? Because you are sending the value 0, also it is a 0. 256 also it is a 0. Okay, so there is a misinterpretation. So 8-bit char only, it is 0 to 255 only. More than that, it will execute, but it will give the, what is that? The wrong errors. The error won't come, but it will, what is that? It will print, but what is that? It is a misconception. The next, what is that? 257, 1, 2, okay, 4. Okay, now you see it is a 510. It is a FE. Okay, 255 plus 255, it is a 510. Okay, so it is FE. The next FF, it's get over. Again I started the third cycle. Okay, first ring over 0 to 255, and 255 to 511 it gets over. I know going for the third ring, it's showing it will start at 0 0. The next, what is that? 513 is 0 1. Okay, whatever the value has to be passed, that has to be displayed, but there is a misconception. Okay, why? Because we are using, in this 8051, we're dealing with the 8-bit microcontroller. Okay, so it is 0 to FF, 0 to 255 only we are dealing. If you are beyond that, you give 256, 257 and all, it is, what is that? 256, you convert it into the hexadecimal number, it comes 100. Okay, 257 is 101. Okay, that one, just you leave it, that MSB, the LSB, and the next to that LSB only, it is going to be displayed over here. So these things and all you have to be understand very carefully while writing the program. Okay, so now I taken the positive numbers. Suppose if it is a sign character, the before example, previous example, we seen the sign character, so the value is, what is that? Minus 128 to plus 127. Okay, 128 to minus 1, 0, 0 to plus 127. Already we know minus 1, the 2's complement is FF, minus 2, the 2's complement is FE. Now I will take one example for that, for further better understanding. Okay, due to time constraint, just I copy and paste because I want to give the more inputs to you to get better understanding of embedded C. You see, I use the sign, okay, character. If you are not using sign also, it will take it as a sign character. Minus 129, minus 30, minus 31, minus 32, and so on. Okay, but in the sign character, okay, what is the value it is applicable? Minus 128 to plus 127. For example, I am executing the code. What is the value you are getting in the P1? We will see. The program, everything is same, just this line, just I am passing the different values. Okay, more than 256, 57, what will happen? And the less than minus 129, 130, minus 131, minus 132, what will happen? Okay, now I am going for debug session. Okay, now I am going to be execute. It is a stepwise execution. Okay, now what is the value you will get for minus 129? You are getting 7f. Okay, it is correct. Okay, but in the 2's complement, what is the value for 7f? It is a plus 127. Okay, you see here, it is a sign character, minus 128 to plus 127 only, but you are passing minus 129. The program is, what is that? Sending the value 7f, the 2's complement of the plus 127. Okay, this is what it is. Because it is a signed character number, that's why it is 7f. Okay, 7f means, what is it? Plus 127, but you are getting a value over here for minus 129. So there is a misconception. Okay, whatever the logic you are writing, Okay, here suppose you are passing this value, there is some contradiction. Okay, you have to be must take care of it. I has to be next, it is 7e. Okay, it is decreasing. You see, just decreasing the values. Okay, here minus 128. Suppose it is 80. If you decrease, it means 7f, 7e, 7d, 7c, 7a. Suppose you are giving a more than that plus 128, it will come, what is that, 80. Okay, the 80 for what is that, 80 for minus 128, but come over here for plus 128, it will come 80. Okay, you have to be take care of these things. Okay, now it is a 7e, the next 7d and decreasing 7b, 7a, 79, 78, 77, so on. Okay, so these things have to be carefully have to be dealt. For example, I am making a plus for the better understanding for just two values. Again, I am okay. 129. 129 means what is the value I have to get? Plus 127. 128 means it is what is that? 7 of 80. 81 has to become in the output. Okay, I am going to be run it. Yeah, you see 81, but 81 is the what is the original value for 81? Here somewhere here 81 has to come. Okay, but here it is showing for 129, it's showing 81, and here 82. Again, this is a negative numbers, so this is some misconception. These things and all you must aware of that for write the effective embedded C programming. Okay, today I am unable to cover all the data types. Still three more data type is pending that we will see tomorrow. Thank you.